Assalamualaikum warahmatullahi wabarakatuh and greetings to Dr. Maas Paliza. My group will present about PBL assignment question 2. Represent my group is Haziq Zaihan, Alif Imran and me myself Zuleqmal. In this assignment, my group has to do the question number 2, which instructed to us to design a swamped class A power amplifier that monitor the temperature change in a tank and provide a proportional output that is used to precisely control the temperature by using the situation given. This is the question that provided to us. And brief introduction to what we doing in this assignment. What we design in this assignment is class A amplifier. Class amplifier is amplifier that conduct through the full 316 of the input signal. The DC operation point or the Q point of the class A amplifier is set near the middle of the load line. Class A power amplifier is similar to small signal amplifier, except that it will handle high voltage. In this amplifier circuit, to achieve high linearity and gain, the output stage of class A amplifier is biased on, conducting all the time. It means that it will turn on all the time without switch off. It can occur to continuous loss of power in the amplifier. This amplifier efficiency was ranged between 25% to 50%. This compared to other class A amplifier has low efficiency. This situation happens because large conduction angles of input signal, which is 316 degrees, has occurred continuously losses of power in this circuit. So resulting the low efficiency of class A amplifier. And now I will pass to the next presenter, which is Alif Imran.
Okay, my name is Alif Imran. Today I will explain about a Philas table. Okay, first is facts. Water boiled inside the water heater. And ideas is did not know the temperature in the water heater. And learning issues, what is the most suitable component needed to detect water temperature? And action, survey the type of component that is suitable to detect water's temperature. And for the solution is insert thermistor inside the circuit. Okay. Second is for the facts. Owner does not know the temperature and the condition inside the water heater. And ideas, the owner was not aware about the safety of their self. And learning issue is what is the most efficient way for owner to monitor and control the heater. And action is system has to be available to assist the owner to monitor the heater. And for the solution, provide a proportional output that is used to precisely control the temperature with 1 watt load. Third, when the water keeps boiling continuously, it will make the water dry and it will affect the water heater system, so it can cause damage. For the ideas, there is no warning sign that the water is extremely hot. Okay, for the learning issues, why the company not provide the sign so the owner will take an action. An action tells the owner that if the water heater keep boiling, it will damage the system. So for the solution, organize a campaign about the safety when using water heater. And the last one is water boil continuously. For the facts and ideas, there if no one to switch off the water heater. And for the learning issues, what is the most suitable way to make it automatically switch off? And for the action, survey the most suitable circuit to make it automatic. And for the lastly is solution, build and install circuit.
Hello to Dr. Maas. For our first attempt, given in the question, the value of gain is 50. And then we find the value of RE and we sub into the equation and we get the value of RC is equal to 2.6 ohm. Okay. And then using DC analysis, we put the value of RC is 500 milli, which is also given in the question, approximately 500 milli. And then we get the value of IB 5 milliampere and the value of RB is 2860 ohm. After we design it inside the circuit and we get the value of ICQ is 492 milliampere, which is near to 500 milliampere. And the value of IBQ is 4.62 milli, which is also near to 5 milliampere. And then based on the simulation, we get the VPP equal to 1.747 and the value of VPeak and VRMS. And then the value of P out, we get P in, and this is the percentage of power. Okay, after that we draw a graph, and then we find the I saturation. The formula is VCC divided by RC 5.77 and VCE off is equal VCE off equal to VCC equal to 15 volt. And then we get the Q point below, which is actually not a class A amplifier. Okay, for our graph, we get our graph which is out of phase. For simulation, we get the graph is out of phase.
Okay, for the second attempt, first we calculate RC. The formula RC is VCC over IC saturation. And for the IC saturation, the formula is VCC over RC. And VCC we get 15 and IC saturation we get 20. So for the IC saturation, the value is 750 ohm. For VCC, VCC is equal to VCC of and is equal to 15 volt. So for the so next we need to find the RB. So we use VBB minus VRB and minus VBE equal to 0. So RB we get 3 kilo ohm. So for the IBQ is ICQ over beta. So for the ICQ is 469 milli and beta is 100. So we get IBQ is 4.7 milliamp. And third, we need to find IEQ. Formula to find IEQ is ICQ plus IBQ. And IEQ is equal to 473.7 milliamp. For VCEQ, we use the formula is equal to VCC minus ICRC. 15 minus 469 milli times by 20. So we get 4.62 volt. So for the power in, VCC multiply with ICQ. So we get 7.035 watt. and for the P out is IC is from the simulation, and VCE is VCE RMS. So we get IC is 482 milli times by 6.05. So we get 2.916 watt. So from the oscilloscope, VPP is equal to 3.127 minus 3.138. So we get 6.265 volt. And IC peak is beta IB is equal to 100 times by 1.53 milli, and we get IC peak. The value for IC peak is 0.153 ampere. So the power out is equal, we need to use the formula, so we get power out is 0.25, and IC peak is equal to beta IB, so we get the value 157 milli. So for the IC mean, ICQ minus IC peak is equal to 469 minus 157 milli, so the value for IC mean is 312 milli. For the IC max, we use this formula, so we get the value 626 milli. For VCE plus VCC minus ICRC, so we get 8.76 volt. So for the VCE, we use this formula, VCC minus IC max times by RC, so we get 2.48 volt for the VCE.
And now I will explain about graph for coupon for second attempt. Based on what we calculate and simulate before, we got coupon graph for second attempt, which is the coupon is located at the middle, by the ICQ is 469 milliampere and the VCQ is 5.6. And based on the calculation and simulation we do before, the IC iteration is calculated by using equation VCC over RC, and we got 750 milliampere, and VCE of actually equal to VCC, which is 15 volt. Okay. This is the simulation circuit that we design on for class A amplifier by using the VCC 15 volt, RB equal to 3k ohm and RC equal to 20 ohm. We're using the transistor. We got the VRMS equal to 3.977, which is equal to V peak. Then we got the corresponding value of VICQ with 468 milliampere, and that's all.